Today's lesson, we're going to talk about how to find solutions to polynomial equations that do not factor. So a couple of things we're going to talk about first. There's a couple theorems and definitions we're going to talk about. The first one is the fundamental theorem of algebra. It says if you have a function of polynomial degree n, basically that just means any polynomial. It could be linear, quadratic, cubic, so on and so forth, up to whatever degree it wants to be. It has at least one zero or one solution in the complex number system. The complex number system could be real, so it could be 4, or it could be a half, or it could be 3 plus 2i. That's a complex number, and we're going to talk about complex numbers again today in pre-calculus like you did in Algebra 2. So basically just saying if you have a polynomial, there's going to be at least one solution in the complex numbers. A complex number is a real number, but it could also be the imaginary, where it's a real and an imaginary piece to it. So how do you go through and solve an equation that is unfactorable? Well, we have the quadratic formula. The problem with the quadratic formula is the quadratic formula only works on quadratic equations, and a quadratic equation is of the form x squared. Okay, degree 2 is a quadratic equation. The quadratic formula only works if it is a degree 2 problem. So what we have is something called the rational zero test. What you do is you use it to find zeros. So you use the rational zero test to find zeros. So it says if f of x is polynomial and it has integer coefficients, so make sure your coefficients are integers, make sure all your a, b, c's are 1, 2, negatives, positives, zeros, so forth. They will have the rational zeros. Now, remember what a rational zero is. A rational number is a number that can be represented as a fraction: 4, 1/2, -2, -3/4. Pi is an irrational number. An irrational number is a number that goes on forever without repetition. So this is only going to give us rational numbers, and notice what it does. It comes out as the form of p divided by q, where p are the factors of the constant and q are the factors of the leading coefficient. And we're going to talk about what all this looks like here in just a minute when we get into an example. Another definition we're going to talk about is the conjugate pairs. What the conjugate pairs says, if you have a zero or a solution that is a plus bi, so like use an example with real numbers, 3 plus 2i, then 3 minus 2i would also be a solution. And that's what that's saying, is so if you have a complex number, you're going to have two of them. And that comes from where I comes from. I comes from the square root, and what is in front of the square root in the quadratic formula? The positive and the negative sign. So you have a positive and a negative, and that's why you have the conjugate pairs theorem. So let's look at a couple of examples. So first of all, we're going to just briefly discuss these. It says find all the zeros of each function. A zero, you just plug 0 in for the f of x, and you solve. The first one's linear. You add the 4 over, and you get x equals 4. You plug 0 in here, you get x cubed minus 9x. This is a factoring problem. You can factor out an x, you get x squared minus 9. The x squared minus 9 factors, and you get x minus 3 and x plus 3. Set those equal to 0 and solve. You get this one here, x to the 4th minus 16. This is a difference of perfect squares. It becomes x squared minus 4 and x squared plus 4. And what happens is you get x minus 2 and x plus 2, and then x squared plus 4 does not factor any further. So what happens is when you set all those equal to 0 and solve, you're going to get x equals 2, -2. 2 comes from this one. When you set it equal to 0 and add the 2 over, you get 2. This one gives you the -2, and this one, if you set that equal to 0 and solve, you're going to get x equals -4, x squared equals -4, square root both sides, and you're going to get positive and negative 2i. Because when you take the square root of both sides, you get a negative inside the radical, which is an I, which is a complex number, and then 4 is just 2, so that becomes 2i, a little Algebra 2 review there. Okay. Now, what we're going to do over here on number 2 is we're going to solve this one. The problem is it says find the rational zeros of the function. If you try to factor by grouping, this does not factor by grouping. You can group it, you can go through the process. Unfortunately, you never get there. So what you do is you have to do p divided by q. So what you need to do is you need to list off all of your p, all the values that could be p. P is the factors of the constant term. So in this case, it's 1 and 8. 2, and 4. And I always list them in order, 1, 2, 4, 8. I just list them from least to greatest. So that's why I did 1 and then 8 and then 2 and then 4. And all I'm doing is I'm looking at all the different ways I can factor to get 8 using integers. And then I need to put a plus and minus in front of that because each one of these numbers is going to be positive and negative. The reason for that is because if you get 8, that could be a positive 1 and a negative, or a positive 1 and a positive 8, but it could also be a negative 1 and a negative 8 to give me a positive 8. Then you list off all the factors of q. Q is the factors of the leading coefficient, which in this case is 1, which would just be plus or minus 1. So then what you do is you do p divided by q. Well, p divided by q is all your p values divided by all your q values. So 1 divided by 1 is 1, 2 divided by 1, 4 divided by 1, 8 divided by 1. What this does is this gives me options for what my real zeros could be. So then what you do is we're going to use the calculator to make this as easy as possible. Okay? So what you're going to do with your calculator is you're going to go y equals, so you're going to turn your calculator on, and so you're going to go to the y equals screen, and what you're going to do is you're going to graph the function, this function right here, f of x equals x cubed minus 5x squared plus 2x plus 8. So what we're going to do is we're going to type that in, x to the third power, make sure you hit the right arrow key, minus 5x squared, hit the right arrow key to bring that out of the exponent, plus 2x plus 8. Now the reason we're doing this is because if you remember, our zeros are going to be where it crosses the x-axis. So what I'm going to do is anytime I go to graph, I always like to hit zoom 6, and what that does is it sets my calculator to the 10 by 10 x and y axis. So I get this graph here, and notice my graph, it looks like it crosses the x-axis at -1, 2, and 4. So what I know is that x looks like it should be -1, 2, and 4. So then what we do is we check. And now how do we check that? We do synthetic division. Now what's going to happen is you can actually check that with your calculator. So let me pull the calculator back up here real quick. So how do I check that with the calculator? So what I'm going to do is I'm going to look in my table. So if I hit second table, notice I get all these values. If I hit x equals -1, so if I type -1 in and hit enter, notice what happens is the y value comes out to be 0. That's exactly what I want. Why? Because my y value is 0. That's what it means to be a 0, is the y value is 0, the x value is something. So then I do 2, hit enter, and notice when I hit 2, the y value is 0, and if I type in 4 and hit enter, my y value is 0. Now, if you go into the table and your table doesn't look this way, what you do is you hit second window, which is table set, and you go down to the independent, so you hit the down arrow key until you get independent where it's blinking independent or ask, and you want the black box around ask. So you just move the blinking cursor over there and hit enter, and what that does is it tells the calculator and the table that you're going to put in your independent variable, which is your x values, and then that gives you those values. Okay, so that's how you use your calculator. So I don't need to go through and check these algebraically. Okay, that's all we're going to do. Okay, for that one. Okay, so then this one up here, x to the third minus 15x squared plus 75x minus 125, the easiest way to do them is to try to factor them. If they factor, go for it. So what you can do is you can try to factor this. They both have a x squared, and this becomes x minus 15. These both have a 25, so if I take that out, then that becomes 3x minus 5. Notice that doesn't factor. So since that doesn't factor, then I have to do something else. Okay, so I go back in and I do something different. So what do? I do p over q. So p, the factors of 125 would be 1 and 125. 2 doesn't work. 3 I don't believe works. I know 5 does. And I think that might be it. 125 is not one that has a bunch of factors. Now how do you figure that out? What you do is you bring out your calculator, and you just start running through there. 125 divided by 3, hit enter. Doesn't work. 125 divided by 5, that one works. 125 divided by, I guess you could do 6 if you wanted to. That doesn't work. 125 divided by 7. And notice how your results are getting smaller. 125 divided by 8. And once you meet in the middle, then they don't work. But those are the only ways to get 125. Okay? So then what I'm going to do is I'm going to go find the factors of q, which in this case are just 1. So then p divided by q is 1, 5, 25, and 125. Why? Because you take all of these numbers divided by q, and then remember it's plus and minus. So then what we do is we use the graphing calculator. Okay? So how do we use the graphing calculator? We graph the function. We have x cubed minus 15x squared. So if you want, you can use the insert button, and you can insert numbers in. It's just second delete, and that way you don't have to retype everything. So then I'm going to insert 7. Then I'm going to change the 2 to a 5. I'm still on insert. So I'm going to get out of that. So I'm going to delete the 2. And then I'm just going to do 125. And then I'm going to graph that. And then notice what happens is it looks like I have zeros at 1, 2, 3, and then 1, 2, 3, 4. That's not very good. So I'm supposed to have some zeros. Okay, let me make sure I type this in. X cubed minus 15x squared plus 75x minus 125. That's why. Let's go over here and change that. And that's something that if it doesn't work out, make sure you entered it into the calculator correctly. So now let's graph it and see what happens. Uh-oh, my graph didn't show up that time. X cubed minus 15x squared plus 75x. I don't have an x there. Ooh, where'd my calculator go? Alright. I'm having all kinds of trouble with the calculator. That's alright. So there's not an x here, so I have to insert an x. So I just type my equation in, make sure my equation is correct, and hit graph. There we go. And notice it looks like it crosses the x-axis at 1, 2, 3, 4, 5. So what we can do is we can hit second, graph, and then we just type in the number 5 and see if it works. Yep, there it is, 5. Perfect. Now, here's the problem. It is how many zeros are you allowed to have? Okay, you're allowed to have 3. The calculator only gives me 1. Okay? The problem is this rational zero test gives me possibilities, but it doesn't do anything for complex numbers, and complex numbers don't show up graphically. That's the downfall. That's the short version of the downfall of the rational zero test. So what we do now is we do synthetic division. So we know that x equals 5 is a 0. So what we do is we do synthetic division. 5, we put 1, we put negative 15, we put 75, and we put negative 125. Okay? So what happens is you take this 1 and you drop it down 1. We multiply 5 times 1, which is 5. We then combine negative 15 and 5, which is negative 10. We multiply 5 times negative 10, which is negative 50. We combine, which is positive 25. Then we multiply and we get 125, and we get a remainder of 0. This right here has to be a 0. If it's not a 0, then that number 5 is not a solution, or you've done something incorrectly. Okay? Now what happens is this becomes x minus 5, because x equals 5 is a 0. This is the factor form. This right here is x squared minus 10x plus 25. In synthetic division, we remove the variables, but then this is x squared and x. Whenever you do synthetic division, whatever your original problem is, when you do synthetic division, it decreases the degree by 1. Notice this is x minus 5 and x minus 5. because it factors. So what does that tell me? It tells me that the only 0 that I'm going to possibly have is x equals 5. And that's it. Okay? So now what we're going to do is we're going to look at the next one. Okay? I don't know how to factor this when there's 5 terms, so I do p divided by q. So I need to find p. So the factors of p would be the factors of the constant, which would be 1, 2, 3, 5, 6, 10, 15, and 30. Divided by the factors of 2, which would be 1 and 2. So then you have to do p divided by q. 1, so I'm going to list all those. All of these numbers divided by 1 are just all of those. 1, 2, 3, 5, 6, 10, 15, and 30. And then I'm going to do all those numbers divided by 2. 1/2. 2 divided by 2 is 1. I don't need to write it again. I've already got it. 3 divided by 2. 5 divided by 2. 6 divided by 2 is 3. I've already got it. 10 divided by 2 is 5. I've already got it. 15 divided by 2 I don't have. And then 30 divided by 2 is 15. So these are all my possibilities. Remember, it's positive and negative of those. So now what I'm going to do is I'm going to go to the graphing calculator. Okay? I'm going to type that equation in. Right? And I need to make sure that I get it right. So it's 2x to the 4th. So I have 2x to the 4th. Go to the right. Minus 9x raised to the 3rd. Go to the right. Minus 18x squared. Go to the right. Plus 71. X minus 30. And then what I do is I hit graph. And then I look to see where it crosses the x-axis. And hopefully we see some. So if it doesn't show up here in just a minute, then I'm going to go back and double check and make sure I typed it in. 2x to the 4th minus 9x cubed minus 18x squared plus 71 x minus 30, and that's why it's not showing up, is because I didn't go back in and delete all this other stuff, and it was just typing so it just pushed everything to the right, and now I had a crazy graph. So now let's try this again. Hopefully it works out a little bit better. And so notice it looks like we have x equals negative 3. So I'm going to have negative 3. Go to the calculator. It looks like maybe a half, positive a half. And then it looks like, what, 1, 2, 3, 4, 5 maybe? 5. Okay. So we're gonna check those and see what happens. So we have 1, 2, and then maybe x equals 2. Okay. So then we're just gonna check those and see if they work. So now I'm gonna go in here and I'm gonna say, okay, let's go to the table, and I'm gonna check negative 3. So I just type in negative 3. Hit enter. Notice it comes out 0. Perfect. Then I'm gonna check 2. Perfect. And then I'm gonna do 1 divided by 2. That's 1/2. I'm gonna check it. It works. And then I'm gonna check 5. And notice it works. If you can notice, there's only 4 possibilities. There's only 4 answers that you can have. So if I come up with all 4 of them, there's no reason to do synthetic division. Up here, I knew there was a possibility of 3. The graph only showed me 1. I had to go and see if there were any others that weren't showing up graphically. So then I know that x equals 2, negative 3, 5, and 1/2. Those are the only solutions. Okay, so let's try number 3. Okay, that does not factor, so I'm going to do p divided by q. P over q, which is going to be 1, 2, 7, and 14, divided by 1. And the nice thing is dividing by 1 doesn't really do anything. Okay, so those are my p over q's. So then I'm going to use the graphing calculator. I'm going to type my equation in. So it's going to be x, so I'm going to clear this out so I don't have that same mistake. So x raised to the 3rd minus 7 x raised to the second. Always hit that right arrow to get out of that exponent position. Minus 11x plus 14. So when I graph this, okay, it looks like what? Possibly negative 2 and 1. So negative 2 and 1. And then if I go back into the calculator, that looks like 1, 2, 3, 4, 5, 6, 7, 8. But here's the problem. Is 8 one of my possibilities? Nope. So there's something going on there. So what we're going to do is we're going to use a graphing calculator. Okay? So let's just check to see if any of those work. So I'm going to check. So let me make here. Alright, so we're going to hit the second table, and we're going to check them, negative 2. So I'm going to type in negative 2, see if it works. Negative 2 works, perfect. 1. Notice 1 is negative 3, that does not work. So 1 is, actually it looks like it crosses, but it actually doesn't. And then we'll try 8, even though it shouldn't work because it didn't tell us that it was possible. So what that means is that we have negative 2 that works. So we need to figure out what the other ones are, and that's where the synthetic division comes into play. Okay? So we're going to do synthetic division with negative 2. So we use 1, negative 7, negative 11, 14. So then what do? I drop the 1 down, multiply, negative 2, combine, negative 9, multiply, that's going to be 18, combine, that's 7, multiply, negative 14, that becomes 0. Now remember, this is x plus 2 times x squared minus 9x plus 7. Okay? That's still equal to 0. Remember, we're solving the equation. Where did I get that? Negative 2 turns into a factor because you have to have it. It's really x equals negative 2, and I have to move that back over to turn it into a factor, so I have to add it. So that's where the plus 2 comes from. X squared minus 9x plus 7 is the quadratic. This is a quadratic, not factorable, so you use the quadratic formula. X equals negative b, which is negative 9, plus or minus the square root of negative 9 squared minus 4 times a times c, all of that divided by 2a, which is 1. So this becomes 9 plus or minus the square root of 81 minus 28 over 2 equals, simplify that, 81 minus 28, 80 minus 29 would be, what is that, 60, 59. So let me double check so I don't screw up. Started. So 81 minus 28 is 53. Yeah, that makes sense. Okay. So 53. So this becomes 9 plus or minus the square root of 53 divided by 2. Now, if I want to approximate that, which I can, so I'm going to use the calculator, you just do 9 plus the square root of 53. Now, I'm going to hit enter here. I'm going to get that decimal. I'm going to divide that by 2, and notice what that comes up with, 8.14. 8.14. This is an equal sign right here. And then I'm going to do the same thing, but I'm going to do minus. So I'm going to do 9 minus square root of 53 equals, divide that by 2, and I get 0.859 or 0.86. Now notice, we said positive 1 and 8. Notice 0.86 is really close to 1 and 8.14 is really close to 8. What's happening is on the graph you can see what it's close to, but you can't actually come up with those numbers. And here's the thing on the, because what some of you are going to do is you're going to, well, I can come up with those decimals. I want this answer right here. You have to be able to come up with that radical in order to be a proficient or advanced. That's what I want you to be able to do as a pre-calc student, is come up with that number right there. This is a good number, it's approximation, but it's not the best mathematical number. That's what you need to be able to come up with. Okay, and that's all you need to do for that part right there.